Okay, so here we are finally. And bend this video. Okay, good. So last time we started discussing polymorphism, and one of the main advantages we said for object-oriented programming and dynamic method binding, if you remember, was that we had the example where we wanted to basically create, here is our plan, right? Here is how to leverage the powerfulness of object-oriented programming and polymorphism. We're going to create a parent class. This parent class is going to be, let me just jump directly here. This parent class is going to be a kind of a generic graph object superclass or parent class that later we are going to create different childs out of this class, such that hopefully at the end we create our own graphics or shapes package, right? So you can create a circle, triangle, rectangle, point, a square, whatever you prefer out of this generic graphic object. And we said of leveraging this powerfulness is that if you have an area method here in the parent where it has any implementation, we will implement it together right now on online GDB, and we'll see that simply will do nothing at the parent class because that's not our focus. We just have this as a template, right? And then based on whatever the shape is, whether it's rectangle, triangle, circle, we are going to calculate the correct area inside the method of the child class. Well, so far, that's interesting, that's good, but we have already discussed this, I guess, 3 lectures ago. So with method overriding. So what is new here? The interesting part here is by creating, during runtime, creating all the objects. For example, here, as you see, we create an array or a set of graphic objects. All of them are of reference type of the parent, which is graphic object. Then later, based on what you create as an object, so this is the reference. Remember last time we spent considerable amount of time comparing between reference and the object itself, right? Here, the reference is of parent type, while the objects are of child type, point, rectangle, triangle. And simply, if you want to calculate the area, it's enough just to refer to the generic parent reference and then reference the area one. And based on which one or which entry in the array it is, the correct area is going to be calculated. So at the end, let me just visualize before we jump into programming. We have an array here of different shapes or different graphic objects. Some of them will be of point type. Some of them will be of square type. We don't have square in this example. Let's say rectangle type, circle type, I don't know, triangle. Good? And then based on which one it is, as you can see, this piece of code here, the one that is calculating the area or the maximum area, is not really concerned at all with the child type. It's only dealing with the reference parent type, calling the area method exactly the same way for all the entries, and dynamically on runtime, based on which index it is, based on the value of I here, the correct area is going to be calculated. Right? That's very interesting, right? So let's see how to do this. But first of all, let me see if there are questions with regard to the bigger idea. So I will come, so Sky, I will come into lab questions maybe towards the end, but let's make sure we keep the flow. Good. So if now we understand this, let's see how to program such an example. Well, okay, so we don't do this and jump into online GDB. Then remove this. It should pick Java. That's good. Now let's, oh, that's not Java really. Well, that's interesting. Okay, here we are. Good. Maximize a little bit. And then let's start with the parent class, right? So I'm going here to create a new file. I'm going to call it something like graphic object or graphic class, call it whatever you prefer. And then inside this one, we will have our generic graphic object. Let me make sure I maintain the names. So here we define this class. And well, that's a kind of a parent class that later we will create different childs out of it. So what we want as an example here is we only want the area method, but let's say we just have even we don't need a constructor. Let's leave constructors and everything else for now. So here, let's say we have this public, and then maybe we want to return the area as double, and then area takes no input. Then simply here I would just return 0, good, for the parent one, because I'm not interested really on the graphic object itself. And then later on, you want to go ahead and create multiple childs out of it based on whatever shape you prefer. So for example, if I start with the circle one, so let me call it my circle or Java. Okay, and then here, this would be, the name is graphic object capital, that's okay. Public class, my circle, and then extends. Remember, this is a keyword for having inheritance between a parent and a child. And then we want to extend the parent class, that is our generic graphic object. And then here, we want to start looking into the circle class. So what I want basically for the my circle class, first of all, I might need a couple of instance variables, because in circle you need at least the one, like the R, right? So the radius one, and the radius can be double. So here I would say double radius. And then you might need something like a constructor that has it like everything as 0. Remember the steps we said, you need instance variables, constructors, getters, setters, and then let's focus for now in the area one that we are interested in. So I'd say public, and then I'm returning double, then area. In this case here, we called this previously, if you remember, method overriding, right? A child that has a method with the exact same name and signature, like the same input parameters as well as the parent here, right? And then here, we know that this object, whatever object we create out of this circle class, is going to have the area of a circle. So you want to calculate, so let's also have here something like a constant that has the pi value, double pi, then we have 3.14 for now. And then for the area, what I should return is simply 0.5 radius square, right? So radius multiplied by radius, and then that's multiplied by r square. So that's multiplied by pi, right? Something like this. If I have done like bad in calculating areas and geometry, so excuse me for that. But basically, this is how you calculate the area of a circle. Good. Then that's just one example. Let's add another one to play around with these. So let's have, I don't know, like the rectangle one might be. Rectangle. Oh, let's just my rectangle to keep the same naming convention. Then okay. And here I'm having a public. Oh, public. Can I just go bigger? Okay, public. And then class, what is the name again? It's graphic object. Public class, my rectangle extends, and then graphic object. And then here again, you need a couple of other variables. You need, let's say, double x and double y. That's the width and the length of the rectangle. and then you have a constructor, setter, getter, whatever, and then we go to the area, right? For this area one, it's exactly the same one, except we're going to calculate the area of a rectangle, right? So in this case, it should be simply x, x multiplied by y, right? So here we had a couple of implementations for two objects. What else do we have in the slides? We have rectangle, triangle, circle, and point. So let's keep it as only two. That's fine, just for sake of time. And the interesting part is I want to go to the main and create like a kind of a list or a set or an array, basically, of these objects, right? So here in the main, but before writing the test, let me take questions if you guys have. Okay, is there a problem with the circle naming thing? Yeah, here, thanks. And then AK, there is one question, and let's see this one. How would you implement an idea of creating a graphic object project like this, but on a bigger scale? We can't have a file for every type of shape since that's inefficient. So what we thought process idea to be compact everything. AK, so really you might think that having one file, one class file for every shape is inefficient, but really that's the most efficient thing you can have. So if you look into any bigger scale projects, either in industry or open source academia, you will find that you don't really measure the efficiency of the project with less number of files. It's in fact, the more you factorize, the more you have larger number of files, that means this code is easily accessible. So number of files has nothing to do with efficiency at all, right? So yes, I would recommend that for every shape you would have a separate class and a separate file, right? That's from the real case point of view. Does it mean it's wrong to have all the shapes in the same file? No, that's not the case. But in this case, only one of them can be public. And that's a big problem, right? Because you want to be able to access these shapes from your test class or give it to the user, right? Don't need default constructor. Yeah, now, yes. So I just said, let's skip constructors because if we don't have one, then by default, you would have the empty constructor. Then you would have the empty constructor that basically initializes everything to 0 and the references to null, right? So this already exists if we didn't implement it. I just wanted to focus in the area. Good. So if there are no more questions, let me jump into the main and write some code that uses what we have wrote. So I'm going to create an array of 100 elements, all of them out of graphic object. And then here, let me say, I'm just going to have this as divided by 3. And then we don't have a point. What we implemented is only the circle, and this should be circle. And then it takes just nothing, because that's the default constructor. And here we have 3 plus 1, my rectangle, same thing. And then I'm going, just for sake of education purpose, I'm going to create also an object of the graphic, like the parent one, to see that the area is really 0 there, right? And then, well, that's good. Okay. And then what I want to do simply is, here we created the objects, but what we want at the end, we want to calculate the largest, the object with the largest area or the maximum area, right? So the way we would do it is, let me copy this here. Oh, wait, this is not copied. It's interesting. Ah, yeah, it's here. Okay. Wow, that's copied multiple times. So as you can see here, simply we want to implement a method that calculates the largest area. It takes a graphic object as input and brings the largest area out of these objects for me, right? So how to do this? so we need to write the method itself, right? So here we want to implement this this method that is largest area one. So how to do it? Let me take the template and then. Okay, so here. Okay, that's the main one. We should be inside the main. So let's look into this largest area method together. First of all, what I want to return the object that has the largest area out of the array, right? So here I'm returning a graphic object type, which is a parent type. And this is a key that we will visit right now. The second thing is you are taking the whole array of graphic objects as an input, right? You have to go through them all one by one, calculate the area, compare this to the maximum area you have, and if it exceeds, you also maintain the index, right? So what we do is simply I'm initializing my area to be 0. I'm also initializing an index to keep the maximum entry, right? And then afterwards, I do a loop over the length of this array. Each time, and here is the key, each time I'm checking if the area, which is this one, is less than or equal to the certain entry, the certain object, graphic object, and then call its area. If that's the case, I need to update my area to be the new one, and then I update my index as well. At the end, your Imax, we have done this in C as well to calculate, for example, the maximum of a certain element, and you get a similar question in the exam. So simply keeping this index, at the end, Imax will hold, just comment here, Imax holds the index of the object with max area. And I need to go back to large. And then the area itself is in the area variable, right? So I'm just returning this certain object that has the index, right? Good. That's perfect. There is one thing we are missing here such that this code can run. Can someone point out what we are missing right now? So I will take questions, but toString method, AK, that's correct. So simply here we are calling the toString method, but well, we don't really implement this in the graphic object. So remember, when you call the largest area method, you return a graphic object type, but the toString one doesn't have simply a toString method, right? So let's see. I mean, let's not implement it. Let's run. And there is one thing I want you to show. But before this, let me take questions. Okay. Why do I loop do graphic object length over 3? Salah and I guess others are doing like having the same question. So simply here, I'm just going through my array. Let me go to the slides and visualize for you. So we created this 100 element graphic object array, correct? And then what I wanted is simply just create different graphic childs for every entry. I guess we are starting by the circle, and then going to the rectangle, and then creating the parent object one, which is the graphic one. I'm going to call it graphic. And then repeat again, circle, rectangle, graphic, right? Which means in one loop, you really create 3 objects. That means you take 3 spaces in the array. So if you have 100 elements, you really need to divide your 100 by 3 because each loop you take 3 spaces, right? That's the reason why we divide by 3. Yeah, Mark and AK. So again, I will, as I said, I didn't implement the toString. Let's try. Let's see what happens. There is one trick I want to show you. So Yanha, what does the GObject 5? We don't have 5 here. It's 3. But simply what? So let's iterate through I equals 0. If I equals 0, that means GObject 0, right? And then 1 and then 2, which means the first element is a circle. The second one is rectangle. The third one is graphic object. And then for I1, 3 is circle, 4, because if you calculate this, end up being 3 multiplied by 1 plus 1, which is 4, is going to be rectangle, and then 5 will be a graphic object. So again, going here to this visualization, 0, 1, 2, 3, 4, 5. So this is exactly what I'm doing. I'm creating a circle, rectangle, graphic, circle, rectangle, graphic, circle, rectangle, graphic, right? All right, what does, okay, so let me go here and see if there is something. Oh, I see, that's correct. Let me just remove that. Okay, good. So let's try to run this and let's see what happens. Hopefully we don't have syntax errors as usual. Because I copied this quoting thing. So let's just fix that. Let's rerun. Exception thread main at main largest area Java 34. Why do we have an exception 34? And what kind of exception? Null pointer exception. So why is null pointer? So we have graphic object with the exact same name. That's good. And we are creating 100 here. We are taking the length by 3. Each time we have my circle, my rectangle, and graphic object is the same one again. Okay. And then that's why that's null. This is because we don't have the toString. Really, the toString shouldn't return problem. Well, why is the loop then the object length? Because again, we are creating for every loop, we are creating three objects. So as I was visualizing right now, right? But let me see if we implement the toString method, this will work. So simply, let's do this here, public, and then toString. I guess it was void if I remember, toString. And then here, I'm just, oh, no, it was returning a string, if I remember correctly. Then I would say return, say something like, you see what we're printing here, largest area, this object. Okay. This. Okay, so I'll say area equal, and then I would just, for this one, I would say 0. And let's go here and overwrite for some of them. That's interesting. I don't think, honestly, this is going to fix it, but let's see. Area equal, and then I can just return the value of this. Or even have a third value here that I can call area if I want. And then here I would say area equal this. And then return area. And then here it would be area. Okay. And then let's also have the similar terminology. I'm defining a variable that is called area. And then inside the area, I'm just assigning the area to be x multiplied by y. And then return this instead. And when we come to the toString method, I'm just going to return area. Well, let's see. Yeah, so it seems that there is a problem with this one, which, to be honest, I'm not very sure why that's the case. Even the arrow is not very representing.
Check the chat. It's the for loop, I think.
Which means one of them, because it's not divisible by 3, this is, guys, what you're referring to. Okay, so, well, that might be interesting. So let me ask you then, if that's the reason, if we have 100 elements in an array, and we are only filling, so by default, because we don't have the constructor, so by default, it will be a null 1, right? So which means I don't create the object. What should I do? Is there something I can do in the largest area to basically make sure I avoid such mail behavior from the user? What do you think? So all you guys, what you're saying, Salah and Michael, you are referring to fixing this in the for loop itself. But what I'm saying is, assume you have your largest area method somewhere else, and simply you don't want to be dependent on the correct behavior. Correct. So Mark, you need to check, and if statement AK as well, that's correct. Sarah, you are correct. So I need to check, and that's a perfect point here. So I'd say if GI is simply not null, then do all the work you do, right? And then, well, else, let's say I just don't consider this for area calculation because it's null pointer anyway, right? Come on, 9 GDB, stupid. Okay, so here, the largest area is areas equals 0, and basically because simply everything. So by the way, maybe I shouldn't answer. Maybe I should ask you, why here did we get the largest area is 0? What do you think? What might be the reason that simply all the 100 elements, 99 elements that we created, empty constructor? Nicole, thank you. Yeah, Katie, Daniel, that's the case. So simply all these objects, well, we don't have initializations, first of all. The second thing is we don't have a constructor that initialize. And what we said, if you don't have a constructor, there is an empty constructor by default that is going to initialize everything to 0, right? Which means if you calculate the area will be 0 for all of them, right? So if we want to simply just modify this, I might have a constructor. I would say, for example, I would say a public, and then, or even just forget about public right now. I would have a constructor that's called my circle, and this one takes nothing. But when I go here, or maybe even take the area as an input, well, we can have this as a constructor and the other one as another constructor. But for now, for sake of just checking, let's have the radius initially is 10 if the user didn't initialize anything. Otherwise, maybe I have another constructor that takes double r as an input, which is the radius, and then now I can assign the radius to be equal r, right? And then I come to my rectangle, and well, I can do exactly the same thing, right? But just for sake of testing, if we run right now, this gives you something, right? How do I know that this is coming from circle? Another thing that I can do for the toString is to say area of circle, and here area of rectangle, right? Something that is telling me which object I'm in right now. And then if I run this back again, well, as we expect, the largest area should be out of the circle one, right? Area of circle. Good. So questions before I go to the trick that I wanted to mention about toString. Do you guys have questions about this example? Do you see basically the main point here is why I would have this? So do you see how just writing exactly the same line of code chooses different method based on which object in the memory it is right now, right? And you don't have to care at all, right? So questions, do you have questions? Okay, Sarah. So the benefit of this is that you can call the same method for different classes at once. That's correct, Sarah. And dynamically, so I would say if I make this more generic than what you said, is I can call the same method and dynamically I can choose, or basically my program will choose which one to pick based on the dynamic behavior, right? How would you assign distinct variable for the radius for each my circle iteration? Well, you can just randomize, or you have a constant thing that keeps the count. Jack, there are multiple ways, right? I guess that was a side question, but can you please explain the null part again? Yeah, so what I was saying here is we had one problem in this for loop that simply if you divide 100 by 3, that's an integer division. So you are going to stop at simply initializing 99 objects because 100 is not divisible by 3. In this case, element number, well, the array from 0 to 99, element number 99 is going to be null one because we didn't simply create the object here. And I would say, yeah, so we didn't create an object. If you go to the largest area, you are passing the whole array and you're doing the for loop over the whole, all the elements, right? If you reach the one that wasn't created in the memory, that's a null reference. And in this case, it was giving an exception, right? Because the null reference doesn't have the dot area method. So, well, one way to fix this is from the original for loop, but the better way and the more professional way is to have a guard in your code against the bad behavior, similar to what we have been doing in our labs, for example, and you check if your entry is null, then you do nothing, but if it's not null, you calculate the area because it makes no sense to calculate the area of a null point. Okay. Then, that said, let me ask you one important question. Assume now I go here and comment out the code for the toString method from all the classes, right? My circle and my rectangle as well. And then here, well, do you remember yesterday trick question? So let me ask a similar one. So I don't have any .toString method in any of the parent or the child classes, but now I'm using it in my main. So what you would expect to happen, right? Error, Yanhao. I will come back to your question, Arjun, but let's first finish this point. Error, Yanhao is saying we might get an error. What you'd expect, what others might expect? Well, you are calling a method that you declared no way at all, right? Like it's not here, it's nowhere, right? So we didn't implement. So having an error is kind of a logical thing, right? So let's try to run and see. Well, it runs first of all, and then also it gives me something, my circle at something, something, something. What is this? Why that's the case? What do you expect? Is then an address toString is inherited from a parent class. Mark, toString is built in a method or something. Nicole, you are close. Mark is correct. So simply remember what we said before. If you don't have a method in your child, but you have it in your parent, and you call the method, simply you inherit it from your parent, right? We didn't have this toString in any of these classes, which means for sure, at least the graphic object should inherit it from somewhere, like the parent itself inherited it from somewhere. So if I go to the slides and to show you what we have right now, we have this graphic object class that has multiple childs, 3 right now, the circle one, the, oh, we only had 2, the rectangle one, right? None of them has a toString method, which means for sure the graphic one must have inherited from somewhere, right? So this takes us to another thing that we want to discuss in this lecture, which is what if my class does not inherit anything from other classes? Does it mean it's not a child? There is no inheritance? No. By default, any class you write in Java is really a child of a general class that is called the object class, right? And then that means the graphic object is by default a child of the object class. This object class has some methods, some utility methods, and toString is one of them, right? This is why even not implementing toString, you inherited it from the general object class. So the object class, as I said, it's the root of any class hierarchy in Java. And if you check using the instance of operator that we discussed before, you will find that any class, whether it's circle, rectangle, and the one that we wrote, which is a graphic object, it will be an instance of the object class, right? And it has some methods. Let me just go here. Well, not this one. Yeah, it has some methods, including, for example, toString. And this toString returns a string that is representing the object itself, like the type of the object. This is why it returned to us my circle, because it returns the class name, right? It has other things like clone, equals to check whether an object is equal to another object or not, or get the class, which returns the class of a certain object. So it has some utility methods that you really don't need to know. But just to show you that by default, you inherit the toString method from the, I would say, the parent of every parent, which is the object class. Good? Okay. Any questions so far? Okay, good. So again, if you check an instance of operator, as we said, so for example, T here is my triangle. So T will be an instance of my triangle. That's correct. And then also because my triangle in this example is a child of graphic object, so it will be also an instance of the graphic object. Remember that we said inheritance is a relationship or is an instance of relationship, which means if you have an object of the child type, it's also of the parent type. So here T is of type my triangle as well as graphic object as well as object type, right? While it will not be for sure an instance of another child class, which is my rectangle. Good. Okay, so another thing that is related to inheritance is assume, for example, I don't want, so I'm a parent, I have some method or I'm a parent class, I have some method or an instance variable that I don't want to childs to inherit from me, like basically take out. So what can I do? Simply, you can use the reserved word or keyword final. So if you define something as final, first of all, if you define a class as final, this class cannot be extended. So you cannot, if you have something like this, you will never be able to have a public class, I don't know, my child, and then extends my class, right? This is not possible. So if we go back to our code, and then I define my graphic object class to be final. So what would happen is, well, I'm not sure if you are able to see my online GDB. I can still even keep the public one. And then if I have this, and if I try to run, well, you get an error because you cannot inherit from a final graphic object, which is getting you to the circle. So it says, really, you cannot extend, right? So if I remove this one, and then I define my area method to be final, then in this case also, you cannot inherit or you cannot simply have this. So let's see, I will not inherit it, but let's see if in this case it can work. So, well, it doesn't work because you cannot override. So first of all, what is the rule? The parent has a method that is called area and it's final, which means you will never be able to have a method with the exact same name as the parent, right? So the parent is really preventing the child from creating a method with a certain signature because this method is defined as final inside the parent. Okay? So this is how, basically, this is a final method, and previously we tried the final class. Questions? Yeah, now, but how does it relate to the add statement on online GDB? So I guess, Yanhao, you were asking about the toString, right? Because this add thing is just returning some kind of an address, so forget about it. if you want to overwrite it to return something meaningful, like for example, only the class name, then you can do this, right? Can you make a child final? Sarah, yes. If you make a child final, then you will not be able to extend this child, but the parent is completely fine. So let's try this. If I do something like this, and I go to my circle and define something like this, my circle to be final, you can expect that I can completely run fine because, well, I'm not inheriting anything from my circle, right? And just to answer your question in a different way, graphic object itself was really a child, right? Remember that we said this is by default extending the object class, right? Which means it's a child, right? So you can make this child final, right? And then if you try to inherit this child for another grandchild, this shouldn't work, right? Okay, good. So going back to the slides. Well, that's good. We have seen final classes and final methods. Something to know is by default, if you have a final class, all the methods of this class will be final and all the instance variables will be final because for sure they cannot be inherited, right? Another thing is that, well, if you have a static variable or a private variable, remember that we said we're going to revisit the private ones. A private variable or a private instance variable or method cannot be inherited. So by default, they are final, right? Because a child cannot use them. It has no access to them and cannot inherit them by default, right? Okay, so static methods. So right now we had method overriding, which means if you have the area, for example, method in the object, the parent one, and the area in the my circle, my rectangle, the one that is at the child will override the one that is at the parent. What if I have a static method, right? So what would happen? Let's see. So simply, first of all, you cannot override it because we said a static method or variable is final, which means you cannot even inherit it. So you don't have access to it, right? But you still can have the same method and with exact same signature. But in this case, we call it hiding, not overriding, because both methods are really not related. There is no inheritance relationship, but the one that is at the child will hide the one that is at the parent, right? So let's have a few examples to make sure we understand, similar to what we have done for the overriding. So here, I have two different methods. One that is not static, which is the toString one. Another one that is a static method, and I call it static toString, which is at the parent one. And then at the child, I have, well, supposedly I'm inheriting both the static one and the instance one. We know that you cannot really inherit the static one because it's final, but let's see what happens. So first of all, what you would expect if I use them? Well, I have the answer here, but let's think about it. First of all, I here define two different objects, one of the subtype and one of the supertype. Again, what is the key? The key is to differentiate between the reference and the object in the memory. So once I see this, what I would do is I will look into the memory. I would see what is the type. Here, it's my subtype. That means your object is of my sub. But then you have B, and it's of my sub. And you also have Q, but Q is a reference of my supertype, right? Then the straightforward one is B, because simply here, the reference and the object are of the same type. So what you would expect is if you print the static toString one, it will give you my sub. And if you also print the one that is an instance one, it should give you my sub, because while the reference and the object are of the same type, no problem here, right? All the problems, if you remember, will arise from the fact that the reference has a different type than the object one. So here for Q, for example, we have the reference of parent type and the object is of a child type. So let's see what happens. First of all, for the instance method, because this is the one that we know. For the instance one, what you would expect? Do you remember what was the rule that we discussed before? for method overriding? My sub, right? Because we said for method overriding, it all depends on the object in the memory, right? So the memory object is of my sub type, then even if Q is of parent type, if you run the one that is in instance to string, is going to give you my sub. That's correct. Why? Because in instance methods depend on the object type, not the reference type. Good. The new information here, and this is the only piece of information that might be surprising, is why here the static one printed my super one, right? That means now your static method depends on the reference, not on the object type, correct? Here it was q.static to string. And because q was of super type or parent type, it implemented my super, or it printed my super. So that means now normal methods and instance methods will depend on the object type, while static methods depend on the reference type. So let me ask one question, just to really make sure we understand why that's the case. These things are like not dictated rules. There is a meaning or an intuition behind them. Why do you think that the static method depend on the reference, not the object? This is completely based on something we discussed before, both in C and in Java, that relates to the static methods. So why do you think that the static method depend on the reference type? What do you think? Any guess, any idea? Their value doesn't change when it gets reassigned. You are close, Katie, but you say it in a convoluted way, right? Static memory never erases, so passes by memory. You are close as well, Sarah, right? So one statement we said based on all what you guys are coming close, but the main point is, remember we said static methods and static instance fields are independent of the object, right? So really you have them even if you didn't create any object. And we tried this before in Java by calling even the parent name, like the class name itself, right? You should be able to write something like you should be able to write something like my super dot static to string using even the class name, because it's independent of the object, right? So if static methods are independent of the object, then they only depend on the reference type, right? That kind of helps you understand why static methods are really related to the reference, not to the object, because they are independent of any object. While instance methods are related to the object that is created in the memory, and hence they depend on the object. Good? Are there any question here? Is that clear? I guess Arjun had an early question. Let me check that. Why do we create the parent graphic object when you only really want the circle and rectangle one? Well, Arjun, that's the whole point. Why do I create my graphic object, for example, or the parent one, if it's just like a kind of a template one? It's a placeholder. It has nothing to do. The area is just 0, and it's not a real graphic object. Why do I do this? We do this mainly because you want to go, if I go back here, I want to be in the main or in the testing or my general code and be able to refer to all the entries of a certain set without needing to care about the circle or the rectangle, right? Why? Because from what we said last time, you can refer to a certain object in the memory by the parent reference, right? That's the whole point. One of these, for example, this circle one is in the memory a circle object, right? While all the references we have here of GI, these ones are of parent type, right? And the whole reason, the whole point behind having all of this is that you can really refer to a child object, which is the circle or the rectangle, by a reference of the parent type. And now you make referencing and your code completely independent of the object type. If we didn't have this parent type, how I would write this piece of code? Can you imagine? Every time you want to check the entry type, whether it's circle or rectangle or graphic, and based on this, you would call the corresponding method of this object, right? Otherwise, it wouldn't work. You cannot make it independent of the object type without this polymorphism powerful point, right?
Right. So I understand that. My question comes from, because you have the loop create a circle, then a rectangle, then just a parent graphic object. Does the parent graphic object need to be created?
No, not at all. Not at all. We just created it for sake of, if we want to print, for example, what would be the area of the graphic object would be just 0, right? So if you didn't have this, well, that's completely optional. It's nothing. And in fact, every one of them is also optional. It's based on what you want to do, right?
Right. It's just, I understand why you need to have them as subsets of the other, so you can overload the method and not have to write specific based on the type. But my confusion just stemmed from whether you needed to create a graphic object.
No, you didn't. I see the point. You didn't. But just let me make one small comment about what you mentioned. Is all what you said is correct, except the terminology. You said because I want to overload the methods. That's not correct. I want to override the methods, right? Overloading is a concept that is not related to inheritance. Overloading means you have the same method with different set of input parameters, right? Remember this? So we need to differentiate between method overloading and method overriding, right?
Right. Okay, I understand.
I guess what you meant is overloading in the sense of the meaning of the language, but let's stick to the correct terminology to make sure.
Yeah. Okay.
Yeah. Okay. Good. Yeah. Thanks, Arj. Yes, Sarah, we discussed method overloading when we said, for example, I can have different constructors and different methods that take different set of inputs and which one to call. We had really one lecture on by examples, and we coded this in online GDB. And yes, as well in the lab, you already have that. Okay, so good. So let's continue. We discussed all of this. We discussed the final one with its example, hiding as well. And then here, I guess there is another example of hiding by simply having, so let's see what we have here. Oh yeah, so we are trying to hide a variable rather than a method. So here we have the x value in the parent class. And then in this constructor, we initialize it by a certain value, and we have an end get x that returns something. Here we also override the get x by returning the x value of the current one. And then we have another method that we call get super x, just to return the x that is at the parent one. If I go to the main and try to run these, if I have something of the subclass type, so sub here is an object of simply the reference. Again, what is the question that we should ask? First of all, what is the reference type? It's the subclass. What is the object type? It's subclass. So that's easy, right? Then sub.getX would be simply based on method overriding. It would be this getX, which means it's going to return the value that we see in the subclass, which is 100. While if I want to return the value that is seen by the parent, then I should use the other method that calls super.get.x value. And what is the super one? What we said before, super is like this, but for calling the parent, right? And we have used it for constructors before. Good. We also went through this. Okay, so I guess that's all for today. Let me take few questions. Yeah, I know we went a little over time. So you guys are free to leave, and let me stay for a few minutes to take questions if you have any. I guess some of you had questions about the lab marks. They should be out by today. Yanhao, can you repeat again the part of hiding? Yes, so simply we have two different type of methods. The first one is hiding. The first one is static. The other one is the normal static one, the normal instance method. For the normal instance method, this is the one that we're discussing from the previous lecture. And in this case, we know it depends on the object type. For example, let me have an empty slide here. Oh, I stopped sharing because I was sharing the full screen. So what I would do is new slide and then share back. Okay, so again, we have an object, and let's say this is of child type. And we have a reference, and we can have different cases. Let's say I have a reference of the parent type, right? Now I have two cases, a normal instance method and a static method. In the static method, which method to call will depend on the reference types. You will be calling the parent method. While the instance method or the non-static method, you will always be calling the one of the object type, not the reference type. What is my object type here? It's the child one. So I will be calling the child method implementation. We call this method hiding, and we call this overriding. Why hiding? Because there is no inheritance relationship. We said static means it's final by default. So if you implement the same method as the child, it's not really related to the parent one, right? Because these are completely two different methods. While for overriding, well, the method at the child inherits the one that is at the parent and overrides it, right? I hope that's clearer now.
Yeah, and I just wondering how does it work in this way?
Yeah,
Like,
so it's exactly as I was just drawing right here is, yeah, sorry, go ahead.
Yeah, as you said, the static word is mean something.
Yeah, static means it's not inherited, and simply if you have a static method similar to the example we had here.
Oh, because the static is not inherit, so
correct.
You will only
be
go
calling
to the parent.
Yeah, if your reference of type parent, that's correct.
Yeah, I missed that quote, so I was wondering.
Okay, yeah, sure. AK, are we allowed to use predefined methods in our own methods in the lab? So the dot length one you can use. The general question is you really don't need any predefined method. And in some questions, if I remember in the lab document, you have the constraint of not using any built-in method. So if there is a constraint in the lab document, please stick to this one. If there is no constraint, well, you are free to use. Sarah, when are we going to be done with the material for this course? Considering the exam is the day after the last day of classes. I hope we will be done before the end of, I'm planning to keep the last couple of lectures, hopefully, or at least one of them for revision. So I hope we finish soon. There is only one, I would say two, but two related topics that I want to bring other than inheritance, and then we will be done. Are we allowed to use predefined? I guess I already answered this. So in static hiding, in order to access the child method, you would need and assign it to a new name. Yes, Katie, you need to assign it to a reference of the child name. That's correct. Sky, how many lectures in total? I would guess I would need to visit the lectures that I have and see how many ones are left and how many lectures we really have left until the end of the classes one. So I might answer this question in the coming lecture because it will depend on really how many slots for lectures we have remaining. Okay, good. The other thing is also for the coming tutorial, I'm going to use it to implement or review some of the Java questions to be prepared for the final because we are done with lab tutorials. So next tutorial will be a more of a revision or visiting or coding together, similar to what we do for other tutorials. Is the exam another coding test? Yes, Karina. Yeah, it will be a similar format. Sky, I'm not sure. Let me make sure I will have a clear answer by next lecture, which is on Friday, because I need to see how many slots are remaining and what are the topics that I believe are necessary for you to have for OOP programming, and the ones that you need for 2SI as well. Okay, so if there are no more questions, then I thank everyone again and see you all on Friday. A lot of you have one question. I have a question about the past midterm and the lab. I tried emailing you and the TA, but never got a reply. So a lot of you were in the yesterday office hours. Is that correct? Or
no, it wasn't.
Okay, so can you please email me back again, like just right now, because
Right,
I recall that I revisited every single email about the midterm, and I don't recall that I. So if I didn't respond to you, please email me today.
I'll just forward the email.
Yeah, and for the lab,
Thank you.
also email me and that like the Salah GA at MacMaster, like the one that is responsible for the lab marking, and yeah, just reply to this thread that you asked about the lab or something like this. Just make sure I also remember what was your question.
Because he never got back to me either.
Yeah, CC me as well.
Yeah,
CC,
okay.
Yeah, CC me for that. Okay. Okay, so yeah, thanks everyone. Yeah, Yan, you have a question?
I
go ahead.
have a question, like regarding to the online GDB one.
Yeah.
When at that time you was removing all the toString either from the parent class or the child class, like at that time I wonder the topic at that time is that are you just saying each of the child class is actually like each instance of the child class is actually an instance
of the parent
class?
Yes, and if you don't implement a method in the child that has the same name as the one at the parent, you just inherit the one that you get from the parent, similar to the toString one.
Like, but on that example, you don't have toString either on the child and parent.
Correct, and the whole point was that even the parent one, which is graphic object, is also a child of the object class, which has a toString method, right?
One second, can you say that again?
Yeah, so every single class in Java is a child of a parent class that is called the object class, right? Going back to the slides.
Yeah.
Yeah, and this one has a toString method, right?
Oh.
So we inherit it from there.
Oh, I see. Oh, that's
here, right? These are some of the methods in the object class, including the toString one. Yeah.
I see. Okay, got you.
Good.
Thank you.
Yeah, welcome.
What does the default toString do? Sorry, I just wanted to confirm. Like if you don't override it.
Yeah.
What does the default one do?
Yeah, it returns yeah, this is what we had at the beginning, Arjun here, is it gives you simply the class name, which is my circle, right? And then it brings some kind of, I guess this is a random value or an address or something. I'm not sure what is this. But simply what it tries to print is the class name, which is my circle, right?
Right, and then some kind of reference to that.
I guess sometime, yeah, maybe the address of the reference. Yeah, that's correct.
Right. Okay, thank you.
Yeah, welcome. How many questions will be on the exam in total, and more specifically, how many in each language? So Sky, so 1/3 of the exam will be C and 2/3 will be Java. The exact number of questions, I might be able to have more hints by next week because I didn't simply board the final yet. So I will let you know by next week. Okay. Are there any other questions?
Yeah, I have one more.
Yeah.
So I just want to be clarified. So for the overriding method is stick to the reference. Like
overriding method stick to the reference.
Yeah, like I'm kind of like I'm not sure. Like, did you say like something is stick to the types, something is stick to the reference?
We have an object and we have a reference to the object, correct?
Yeah.
And if you have the object and the reference of different type, specifically if the object of parent type, if the reference of parent type while the object is of child type, here comes all the play, right? The instance method will be depending on the object, right?
Sorry?
The overriding method, like whatever method you want to call, will depend on the object type. So if the object's of child type, you will be calling the method at the child, correct? While for static method, it will depend on the reference type. That's static, right?
Yes.
Yeah, that's all, I guess. What?
So whatever it references, it will goes to that method.
Correct.
Instead of, I see.
Independent of the object type. If it's static, that's correct.
So static is kind of stick to the reference. Okay.
To the reference, yeah.
Thank you.
Welcome, Yana. Okay, so are there, I guess there is also something on the chat. Sky, how many questions will be? I guess also, could you maybe have a review lecture session to go over the most important things for the exam? Yes, I hope maybe at least the last lecture or the last two would be exactly for this. Again, as I was saying, the coming tutorial will also be a matter of kind of revisiting or solving some problems as a preparation for the final as well. Yep. Okay, so thanks everyone, and I see you all on Friday then. If there is nothing else on the chat, let me recheck. Yeah, thanks, Sky. And then, yeah, thanks everyone. Talk to you in a couple of days. Have a great day. Bye-bye.